Question 5, Berlekamp-Welch. Alice sends Bob a message of length 3 over Garlow field 5. Bob receives this message that corresponds to these x values in that order. Assuming that Alice is sending messages using the proper general error message sending scheme, set up the linear equations that, when solved, give you the q of x and e of x needed to find the original p of x. So we know that q of x, which is the received message, takes this form, e of x times p of x. And q of x, the form that it takes, since it's a polynomial, is a of n times x to the power of n plus dot 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 a of 2 x to the power of 2 a1 x plus a0. And we know that e of x, the error polynomial, takes this form, x minus b. And for finding the linear equations that we need to solve the linear system, we can plug them in to this q of I, which is the received polynomial at that index, multiplied by r of I, which is the received message, times e of I, which is the error polynomial. So, and since we know the q of I will take the following form, a3 times x to the power of 3 plus a2 times x to the power of 2 plus a1 x plus a0, since it's of degree 3. And just plugging this in for each of the x values that we have, when x is equal to 0, we have, if we plug in 0 for all of these x values, we just get 0 plus 0 plus 0, since a3, a2, a1 are cancelled out by the zeros, plus a0, and set that equal to e of I, which is, again, r of I times, or set that equal to r of I times e of I, which the received message at this point at x is equal to 0 is 1. So it would just be 1 times x minus b, which x in this case is 0. So 0 minus b. And all of these needs to be taken mod 5 as well, since we're working over that Galois field. When x is equal to 1, if we plug in x equal to 1 for this polynomial, we just get a3 plus a2 plus a1 plus a0 is equal to, and we know that at 1 the received message is 3, so 3 times 1 minus b. At x is equal to 2, plugging 2 in, 2 cubed is 8, and 8 mod 5 is 3. So 3a3 plus 2 squared is 4, so 4a2 plus 2a1 plus a0. And the message that is received at this point is 2, so it would be 2 times x minus b, which is 2 minus b. When x is equal to 3, 3 cubed is 27, and so 27 mod 5 is 2, so 2a3 plus 3 squared is 9, so 4a2 plus 3a1 plus a0 is equal to, the message received at this point is 1, so 1 times 3 minus b. And when x is equal to 4, 4 cubed is 64, so 64 mod 5 is just 4, so we have 4a3 plus 4 squared is 16, 16 mod 5 is 1, so just a2 plus 4a1 plus a0 is equal to, the received message at this point is also 1, so it's 1 times 4 minus b. And so if we solve this system of equations using something like the Chinese remainder theorem, we are left with b is equal to 3, or Gaussian elimination. A3 is equal to 1, A2 is equal to 3, and A1 is equal to 3, and A0 is equal to 2.